In our final example from lesson 10.5, finding probabilities of independent and dependent events, I'm going to show you how sometimes using a diagram is helpful when I've got multiple events going on. So here's our example. Using observations made of drivers arriving in Shoreland, a study reports that 69% of adults wear seatbelts while driving. A high school student also in the car wears a seatbelt 66% of the time when the adult wears a seatbelt, and 26% of the time when the adult does not wear a seatbelt. What is the probability that a high school student in the study wears a seatbelt? There's kind of a lot going on here, and it's more than just simply adding the two percentages together, because there's different ways that this circumstance could go down. So what I'm going to do is start by drawing a diagram of the different options that I have. So in my diagram, I'm going to make sort of a tree. So I've got in the car, we've got the adult, and we've got the student much smaller. Now, how could this happen? Well, let's see. First, different options we got. I'm going to call this event A. So event A is the adult wears a seatbelt. So adult, yes. Okay. And event B is the adult does not wear a seatbelt. Okay. Now, along the lines that go with this diagram, I'm going to put in the different percentages. So I was told in my problem that 69% of adults wear seatbelts. Okay. So I'm going to put a 0.69 on the branch here to represent the 69%, which means I can also put 0.31 or 31% don't. Okay. Now, as I continue on, because I'm given numbers for when the student wears a belt with the adult wearing it and with the adult not wearing it. So I'm going to continue on with my diagram. If the adult wears one, the student could wear one. So that'd be event, I got A and B, so we'll call this event C. So event C, student, yes, wears a seatbelt. And event D would be the student does not, student no seatbelt. Now that could happen with the adult wearing it and with the adult not wearing it. So I have to put event C and D a second time. So there's C and here's D. And along the branches, I'm going to put the different percentages that I'm looking for. So what is the percentage of the student wears the seatbelt when the adult does? Student in the car wears a seatbelt 66% of the time when the adult wears a seatbelt. So we'll put a 0.66 here, which would mean that the student doesn't wear the seatbelt 34% of the time, which would be 0.34. Then, let's see, student 26% of the time when the adult does not. So we're going to go ahead and put a 0.26 right here. And the complement to that would be 74% of the time they're not going to wear one, so we put 0.74 along that branch of my tree diagram. So, what I'm really looking for, what is the probability that a high school student in the study wears a seatbelt? Well, that's event C happening, right? So what I'm really looking for is I want, what's the probability of event C? The probability of event C could happen a couple different ways. I could have the probability of both of them wearing the seatbelt, so A and C occurring. Adult wears a seatbelt, student wears a seatbelt. Or, put or right there, or maybe the adult doesn't wear it, but the student does. So the probability of events B and C occurring. Now, when I have the word or involved, that means I need to add probabilities together. Now, A and C or B and C, those are both examples of dependent events. Probability of the student C, student wears it given the adult does, and probability that the student wears it given that the adult doesn't. When we find these probabilities, we have to multiply them together. So the probability of A and C would be the probability of A, which is 0.69, times the probability of C given A. Probability of C given A is this 0.66 number that I had in my diagram. Plus the probability of B, the probability that the adult doesn't wear one, that's 0.31, times the probability of C given B. Well, the probability the student wears it given that the adult doesn't was 0.26. Multiply decimals together, add decimals together. My final answer, the probability in the survey that a student wears a seatbelt is about 0.536. So according to this random survey, about 53.6% of you wear your seatbelts. I hope that the number is much more, because I hope you know that you should wear your seatbelt when you're driving or when you're riding in a car at all times, because seatbelts save lives. So, have a good one.